Okay, everyone, welcome to Taming the Beast on the last day of KubeCon. It's great to see such a good turnout considering last days, typically it's not really like this. My name's Lucy, I'm an engineer working at Uber, and I'm a contributor to Kubernetes. For most of this presentation, I'm going to be playing more of a role as a user of Kubernetes who has a, who has a lot of struggles with resource management. I'm thrilled to be joined here today by Dawn.
Hello, everyone. My name is Chen. I'm the software engineer from Google, and also I'm the tech lead of the Kubernetes Signal since its inception. And I'm thrilled here to be together with Lucy, and together with us, we are going to show you folks a lot of the new tricks with development last 1 year and or a couple years, and to help you to management resources better and help you gain better control and also managing the Kubernetes resource a little bit nice and tamed. Yeah.
Awesome. So, oh, can I borrow the clicker? Ah, yes. So, Dawn, I've been using Kubernetes a lot at work recently, and it's been quite useful, especially for more basic stateless workloads and the more basic stuff we have. But we've really struggled with more advanced workloads and more advanced resource usage. I thought that to show my artistic creativity, I would draw how it feels like to me. It's almost like trying to tame this wild beast to work with our platform. There's a few things in particular that I'm really having trouble with. I was wondering if we could maybe step through them and see if we can work out whether we can do anything better.
Yeah, go ahead.
Absolutely. Let's tame this. Let's tame the beast. Okay, which is the forward one? That one. So first off, it's setting resources at a per container level. It's sometimes it makes sense. Sometimes though it's a bit of a struggle. I don't really want to dedicate an entire slice of my CPU just to some logging sidecar. I just wanted to share it with the main application. There's also a few applications we have where we have one container normally has high utilization at the time another container has a low utilization, and then it flips on the inverse. And really, we have to reserve all of the space for both containers in order to use it. There's no real concept of sharing. You could maybe do stuff in the CRI, but it's really not that great. Is there maybe anything we could do here?
Yeah, of course. Signal, the community have heard this kind of the request for years, and we finally introduced a new feature called pod level resource to the. So the feature actually it is in Alpha 2 in this recent release 1.32, 33. Sorry. So it is allow you not just apply the resource request and limit at the pod level instead of the individual of the container level. Right, so to really dig into how this is work, let's start with how we apply of the resource at the container today. And you can see that from the YAML file, and you have to apply carefully thinking, upfront planning, and how much of the resource you want to apply to each individual of the container. And there's the kind of struggle. You are going to over provisioning for each of the container, and based on their peak usage, and which is need about the cluster level or node level of the resource visiting. And all you are going to risk your under provisioning of the critical application and impact their performance, right? So this is a kind of current approach. With the introduce of this new feature, pod level resource, and you can see that from the YAML file, right? So you are hugely simplify your configurations. So you can apply simply at the pod level, and you can see what is total of the provide boundary, total of the resource request and limit at the pod level. Instead, go to the detail about the container. So you can see that the two container and share of the CPU and the memory.
Yeah.
Do you want to try the demo?
Yeah, absolutely. Yes. That sounds really exciting. Let's see if we can make it work on a real system. I will say this is over the internet, so just be warned. So if I come in here, I have a Kubernetes cluster here. Let me remind myself what I have in here. Good. So if I come in here, I have first off a YAML file here, which I'm going to cap for the audience. So this is just a basic web app, and it has resources. It has a sidecar container that's doing some logging, and it has a separate resource request, right? So let's just apply that to the cluster, pod level before.yaml. Okay. Yes, I should make that bigger. Okay, and I'll just quickly remind you, so resources are at the container level. We're all used to this, right? Now, what can we do differently? Well, let's have a look maybe at pod level after.yaml, which is the exact same application, except now look, the resources are not set at the container level at all. They're set all the way at the top in the pod level, and the pod it's going to share these resources among all of the containers within. So if we now apply this pod, what was the file called again? It was called pod level after YAML. And that's configured. And if I look maybe at the pods, once they come up, which one was it? I can't even remember now. Probably this one. And then I get this pod here, and we go up to the resources. Here we are. So you see here that the resources are now set at the pod level. They're being shared among all of the containers. Awesome. That's really cool. So Dawn, is this something where you have to make a binary choice? Is this something where I either have pod level resources or I have container level resources, or can I mix and match here?
As adults, we want both. We want all combinations. So this diagram shows you how powerful it could be. So you can, I think this is.
Yeah.
Yeah.
This is the one.
Okay. So you can see from this diagram, you can see that you can apply the resource at the container level. You can also apply the resource at the pod level. You can also apply as the combination. So this is actually the highlights of the flexibility of this feature give to us, right? So you can native of Kubernetes. So this one with this feature, you are hugely simplify the resource management configurations, right? So and reduce of the possibility because the misconfiguration based on the sum of the container resource and which exceeded of the node capability. But if for advance of the applications, you want to, for example, for the machine learning of the workload, which has the one data process pre-pile of container, and which require a lot of the resource spec at the beginning. And but also we need to ensure about the machine learning main app and have the enough of the CPU and the memory can do the training jobs. So in these cases, actually you can apply pod level resource, the CPU and the memory as the boundary, as the total ensure of the main application can be making progress. But at the same time, you can set the relative really high limit for this data pod. Make sure they can using some of the resource at the beginning, but not all the time, right? So that's the kind of things you can think about that. Another of the example I'm thinking about, it is application which have the web services along with of the cached proxy, right? So you application, the web services, they maybe have due to the traffic peak, you may be once a while need more resource. But a lot of time, actually, it is the normal. You can set the pod level boundary as the normal usage of those combination of the two containers. So that's kind of pod level. In this case, it's pod level resource give you the guardrail as the whole, right? So since you can think about the pod as a unit, but at the same time, within of that pod internally, you can do the better sharing. You can also set of the peak usage, but at the same time, you can ensure of the normal time and the resource usage.
That's awesome. So this is in alpha still, right? So if you want to use it, you have to turn on the feature gate. But yeah, and hopefully folks can use it and give us feedback. Awesome. So that's great. We have, though, another problem as well. Right now, we're trying to run stateful workloads on Kubernetes, databases, things that are more tough to disrupt as well. And we want to change their resource usage, but this isn't really possible right now. Pods are immutable, and their life cycle is one way. Once you've said that you have this many resources for the pod, you can't really change that. When we run databases, for example, at work, that really can be quite disruptive because we have to create a brand new pod, move everything over, and because of that, we're really struggling. Is there maybe anything that we can do here to make this better?
Yeah. this is a really good question, actually, and require about the pod restart and also container within that pod restart. And it is with when there's the little resource change, actually is definitely introduce a lot of the operational burdens, right? So this is why we start the Signal community started to working on this in-place pod resizing for years. So I just want to glad to announce that in the 1.33, and this feature actually is promoted to the beta, and so that's, and also it is enabled default for Kubernetes cluster. So this feature, just like name implied, and so you can, let's go to the previous. Let's look at the before picture first. And so you can see that, okay, you want to change small, the machine have some of the slack resource. You want to change because due to that traffic peak, you want to change increase of the CPU and the memory. And you have to, today, you have to kill off the running container and rebuild, recreate of the new pod with the new update of the resource requirement, and then it schedulers to schedule that to the whatever node, right? So suitable node. So this is definitely introduce of the disruption, and could be, and then the terminate about the services, all those kind of things, loss of the network connection, all those kind of problem we have, right? So, and also even for them stateful side, it could be cause of the data corruptions too, because those kind of things. So with this in place pod resizing, next graph, a diagram to show. So you just can Kubernetes take that your request and also just dynamic change. And if the node have enough of the slack and the dynamic change of the request, and the services continue run. And do you want to try?
Yeah, this is really exciting. Let's see if we can get it to work. So let's come over to the terminal again. I need to quickly change context. What is it? QCTL config use context pod. What is it? In place, is it? Yep, okay. So in here, I have a series of pods here. Awesome. So let's have a look at these. So if I open up this pod here, it's just running an application. If we come down a bit, so I'm in edit mode. Okay, so say I'm in here and like I want to increase the CPU limit of this pod, right? I've got more traffic coming in, and I don't want to blow up the whole pod. It's running a database or something, but I just want to give it more CPU. So I'm going to come in here. I'm going to change this 600M to 800M. I'm going to write that, and it's been configured. And now if I have a look, if I go QCL get this pod here, YAML, grep 800. The CPU is increased, the CPU limit's increased to 800M. So I've done that without stopping the application at all. I've just given it more CPU with absolutely zero disruption to my users and my application owners. So yeah, that is really, really cool. And it's one of the most exciting features I've seen in Kubernetes in quite a while. But yeah, awesome.
Thank you, Lucy.
So it's not that we can do that with everything. Are there limits here? For example, adding resources is typically quite simple for systems, but taking resources away from already running workloads is a bit tougher. For example, I could see maybe it works with CPU shrinking, but does it work with, say, memory shrinking?
Yes, that's a good question, leading to the next one. And so it's not all application. You can easily need to change the resource, right? So even like not just shrinking, and even like the enlarge of the resource request, like for example, Java application, when you want to readjust of the heap size, and you may require of the restart of the application. So to make this, this is used based on those kind of workload and different applications. So in place pod resizing actually introduce the policy, resize policy. When two options today we support is prefer no restart. And another one, it is restart container, right? So restart container basically just previous behavior, right? The previous default behavior. And for the VPA and integrate those kind of things. And but even with the preferred no restart, we didn't say absolutely no restart. Here's the reason, just like the Lucy just asked for memory shrinking. Actually, it doesn't work very well because that's have the due to of the kernel limitation. So Kubernetes single node community actually work very close with the Linux kernel community. We try to make this better, especially in the single v2, and when shrink of the memory, and this will trigger about the reclaim of the memory. But in the single v2, actually they prefer it is warm killed because the reason there's also have the good reasons behind because they want to make that predictable performance, all those kind of things. So, but we work with them because the different requirements, especially for the booming of the AI machine learning workload and the warm kill of those tasks actually cause a lot of, the cost is really high. So another thing I want to point out, and this feature actually also can work together with the pod level resource we just introduced earlier. And even you can apply of the pod level resource as a whole for the whole pod, but the restart policy actually dictate about the behavior about the container itself. So I want to point out that one. Also, I want to point out there's the limitation, right? So the feature itself, actually, it is node feature. But to make that empowered is a whole feature and make that more useful, and there's the cluster level of the orchestration integration. For example, vertical pod auto-scaling, and even like some workload framework for on top of Kubernetes, like the Ray, and they have their own auto-scaler, right? So all those kind of things we need to integrate. Actually, there's the community. We work with them, and to make that is integration better. So it's easy. It's not like Lucy and have to manually change the YAML file. And so in the future, it will be automated. And also please notice that there's other limitations, right? So currently for the beta release, we are only support the CPU and memory. And there's the other extended resource we are under development. We are thinking each one of the resources actually introduce different type of the complexity to the system because by the nature of the resource itself. So, but we are continue of the improvement of those kind of things. Another small things I want to point out, right? With the even with the in-place pod resizing with those resources, and you cannot change of the quality of the services. Guaranteed job will stay with guaranteed job, burstable stay with burstable. Even you may be changed to their CPU requests and the memory equal, the CPU requests and equals to their limits. And also, static CPU and the memory management actually won't be changed. Because even you change off those kind of things, there's hard, really complicated to dynamic change of your exclusive or reserved CPU and the NUMA node, all those kind of things, right? So another thing I want to point out, we make to simplify, to promote this to beta easier earlier so people can try, give us the feedback. And we also made a decision, it is atomic resizing, right? So you ask partial of if only partial request adjust meet on the node admission time, we will reject the entire of the resizing because that introduces unnecessary complexity to the system, and also is also for the user, it's really difficult for them to reasoning what's the behavior, and for we cannot do that. So that's kind of all those limitations and we have, but please try because it's quite powerful, and maybe in last couple of days of the talk, and a lot of people already utilize this feature and in their production, and yeah, so give a lot of guarantees.
Well, that is really awesome. I think this is a really powerful feature. Actually, let's just do a quick straw poll. Put your hand up if you're planning to use this feature in the future. Put your hand up. Wow. Yeah, actually, I should put my hand up too. That is a lot, but this is a huge boon for us all. Okay, awesome. Why am I over here? Yeah. Awesome. Okay, now this is all really cool. There's just one other thing that we're kind of missing right now. I run a lot of Java services and a lot of services where on startup they have to warm caches or pre-process things, and a lot of the time that means their memory usage, it looks like a big burst at startup, and then it kind of falls off. Right now, I have to give them a dedicated memory all the way through to their startup load, and then I can't really take it away. Even now, I can't do memory shrinking, right? So that means I have a load of idle memory that I don't want to use. I want to use swap, just like in any other system, but Kubernetes is almost allergic to swap. It's not just not supported. If you run a kubelet with on a machine that has swap, it immediately blows itself up. So Yeah, it would be really cool if we could maybe use memory swap for at least for burst memory in Kubernetes. Do you think maybe we can get to that as well?
Yes. Can we go to next one?
Yep.
so yes, we actually working on the node swap support unfortunately, this time still is not graduated to the GA, and you can see that this is for last many of the improvement. Every release we have improvement on the node swap features, so in the 1.33, and we promoted to the beta 3 or beta 3, I think, and add more enhancement to the features. So I just want to say something. In the past, as the Signal and the community tech lead, I'm really strongly against of the enable of the node, enable any of the format of the swap usage. One of it is the kernel limitation, right? So the top reason it is because they introduce performance penalty associated with the performance penalty, right? So, and also kernel cannot really accurately detect what's inactive the memory. So and also we don't have the really good way to detect those kind of things and to carefully calculate how much of those inactive memory can push down to the disk. And also those disk activities, exhaustive disk activity is really, really slow, and also exhaustive disk activity could be introduced the neighborhood noise, right? So of impact not just itself, the application itself's performance, and impact the entire of the node, other applications' performance. Not just that, and also kernel. Once you enable of those swap, and the kernel will spend a lot of time to try to reclaim, push those pages to the disk, and instead of spending the time to really run off the applications, right? So there's the thrashing all over, also associate those kind of things. So that's why. I strongly against to support of the node swap, but at the same time, we realize, because we evolve Kubernetes, we support the stateful site, and now we are support of the batch workload, and also especially for those AI machine learning, large scale of the Gen AI machine learning training jobs. So, and we know, and resource management and planning is really hard. And care of those certain job, actually it is at more cost to push those certain of the pages into the disk. So that's why we started to accelerate of the development on the node swap, memory swap. So that's kind.
This is the before. Yeah.
You can see that the feature actually it is the at this moment the feature actually is node level feature. You can see the Kubernetes actually play a control plane. Major control plane here, and so Kubernetes you have to configure under this node and enable of the swap or not. Right? So Kubernetes will do the carefully how much and the monitoring of the resource usage about those kind of things. Kubernetes also will be based on the both of the raw memory usage and also swap usage, and make decision when there's the still cannot prevent and make decision. Okay, so this is, but this one actually means node level of the swap. We still not really finish give the pod level and make the application like a pod for free to using those swap. Right? So we are continue work within the community and try to make that final grade of the control for each of the pod and the applications. So
also, this sounds really cool. Maybe we can give this this a go as well. Okay, so if I come over to my terminal here, let's see if I have access to the cluster first off, because I've been fighting with it this morning. Yes, I do. Awesome. So on this machine here, I'm running a basic cluster using kubeadm. If I just have a look at my swap, I have swap memory here. If I have a look here, and sorry, yes, let me make this bigger. So you see here, I'm on a cluster. This is a single node cluster. I have swap memory here, and it's being used properly. If I have a look at my kubeadm configuration, you can see here that I've turned on the node swap feature gate, and I've said that the swap behavior is limited swap. So that means that the burstable component of the memory of workloads can end up in swap. What's the burstable component? Well, if I have a look in and I cap, actually, let's cap the live pod, qctl get pod. Okay, let's cap the file. You can see here, so the requested memory is the part that's non-burstable, and then once you're above your request but within your limit, that's the burstable part that in limited swap can end up, in limited swap mode can end up on swap memory, and then there's another mode where you can actually end up with all of the pod memory on swap. Okay, so that's really, really cool, and yeah, unfortunately, I don't think the cluster is going to cooperate with me today. I don't know. No, it doesn't like me. Okay. I think it literally just crashed mid-demo. That was bad timing. But yeah, that's really cool, though, as a feature. Let me put this slide back.
Two out of three succeed.
2 out of 3 is way better than we thought it would be. So that's great. So I guess now that, so I work at Uber, so I guess that's great because it means that with like many petabytes of disk space, that means that I have like 8 petabytes of RAM now, right?
Yes.
Totally, right?
Yeah. So that's why you can see the demo of the node swap field. That means that indicate how cautious we are trying to use the end of the node swap. By default, even node swap feature, it is GA'd. By default, we won't make that is available. I want to platform admin carefully thinking and plan and how, when they will want to end of the node swap. Okay. So I talk about a lot of those, using is cautious. And there are more of those kind of things. Most of the things I already mentioned that earlier. And they also have the security, right? So security concern. So, so the reason of this time, it is not graduate to the GA. Mostly it is because of security concern. And another one, it is the eviction management that potential punish the good behavior of the pod without using swap. So that's why we connect think about we need more sort through. And but that's kind of thing. But each one of those kind of things actually have the mitigation suggestions. So we are going to document those mitigation and best practice to enable those feature. And so looking forward of the feedback when you try in your cluster, production cluster, yeah.
And awesome. And people, please turn it on, use it, maybe give us feedback. Okay, awesome. Well, thank you, Dawn, for helping us tame. I've got a microphone on here. Thank you, Dawn, for helping me tame the beast. Okay, so now we're going to go into and talk a bit about maybe the future of what may end up happening in Kubernetes Ignore. Before I talk about this, I just want to be very clear. I'm a human who has opinions, which is the most dangerous thing of all. But when I say something, that doesn't necessarily mean that it's a promise, and it doesn't mean that other maintainers in Kubernetes agree with me. It is an opinion that I have, but it is not a commitment to anything particular. But I want to start by maybe thinking about why Kubernetes is so ubiquitous. And I think it was Clayton Coleman who said it's because it can run most things reasonably well. And that's a really good baseline to maybe set ourselves towards. The landscape, though, of workloads that are running in Kubernetes is changing, and it's changing all the time. And over time throughout the project, we've been getting maybe better and better at running more things reasonably well. If we look at maybe at the start of Kubernetes, you have a basic web service, basic cron. This is what Kubernetes really started with. 2016, you have the advent of the stateful set, which deals with basic stateful workloads. Eventually, there's progression of features so that it can get better and better. 2020, you have the job set object, which helps you run batch workloads in a much more better way. And we've talked today about these new features that they could help you, for example, run developer environments. I know that in the past, maybe we've not had the best support for this. I know that Gitpod was on Kubernetes and then left because of the challenges they were facing. With this, for example, with in-place resizing, a lot of developer environments require a lot of resources when you're building and compiling, but not many when you're just writing code. This kind of allows you to respond to that. Also, more advanced stateful workloads, things that are less able to be disrupted. These are easier to support with these new features. But we need to keep relevant with the industry, and we need to be in it. In my head, it shouldn't take you being a maintainer to run your workload on Kubernetes, as long as it's not really crazy, right? Most workloads should be able to run in a reasonably well fashion. So with that, maybe, Dawn, do you maybe want to talk about what we're looking at next and how this ties into what may come next in Node in Kubernetes?
Thank you, Lucy. And you're lucky, have the two most opinionated people on the stage.
That's that bad combination.
Now it is my opinion and also my proposal. So I've been trying to propose those kind of, just like what Lucy said. And I always believe we can evolve Kubernetes to support more workload, even most of the workload, right? Like the last couple of years, we even signaled make the Windows container supported here. So that's why I always believe we can do that. So, but I also know that today's Kubernetes make a lot of the primitives to support certain workload, like for example, those complicated batch workload and the Gen AI machine learning workload. We can support, but we don't do good job, and it's really paying for a lot of the users, right? So, I want to talk about one of the proposal I made last year is pod grouping, right? So, and Kubernetes today only have the pod concept. Of course, there have the high-level concept, the job set, and the replica side, the daemon side, tons of those kind of things. But each one of them have that special meaning and a special, and also it's top, right? So it's not the first layer on top of work to direct with the control plane and work, no control plane, direct with the scheduler, right? Scheduler thinking about is the per pod. And so this is one proposed, especially it is addressing the need of the distributed of the batch workload. We introduce, okay, it's not called the pod group, and it introduced pod group lack of the concept, first line of the concept that describe those workload I want. And so then that require of the group of them, they can co-located and the tight couple of the container, all those kind of things, right? So I want this is kind of a fundamental of the building block, and so all those kind of things can be grouped together, and so enable of the hierarchical scheduling. When I talk about hierarchical scheduling, it's kind of like the Ray autoscaler and the Snurm scheduler, and also like the this week and announced of the Kai scheduler, and by the run AI, and so all those kind of things. I'm thinking about those pod group on top of the Kubernetes, and the people can naturally build about their own Ray cluster and a Slurm cluster on top of Kubernetes. So then we can, and also the whatever, and for other customer of the customized of the scheduler, right? So another things, so that link about the proposal, and another one. It is I want to relax off the constraint. Like today we talk about pod level resource, right? And we also talk about which is make this is happen, and we also talk about in place pod resizing. Or it is make a pod less static, right? So this one is I want to further make a pod less static. So you can inject, you can remove, add and remove of the container, right? So into a pod. So when you have this feature and together previous feature, pod group actually represent a workload, batch workload, right? So then the batch workload control plane, they can schedule about their tasks and jobs into those pod group. And inside each pod group, and inside of each pod, they can schedule their tasks and jobs also. And when you need more resource, you can also enlarge of your pod. And if you don't need that much resource, you can shrink or you can share with other jobs, the application on the same node, right? So there's a lot of the things we can do. So this is kind of like we are talking about this one. So I mentioned this kind of things, and for example of I've been signaled, and I myself.
That's why we have 1 minute.
Actively work with the Ray and the Snurm community, and also we just discuss with the Kai scheduler people and how we can group together. The ultimate goal for me it is define another layer of the abstraction on top of the Kubernetes, and so the batch workload can work on top of those kind of things, right? So just a little bit similar like Signal actually start about the DRA, and then that is built of the abstract layer on the standardized all those specialized of the device. So there's another layer we want to build. It is on top of the pod objects. So then all those kind of the customer or the batch workload, the scheduler can schedule target to the pod group together.
I think we may have to. I think we may have to be very bridged here.
Yes.
Okay.
Go ahead.
No. Do you want a quick like? No, actually, yeah. We need to go forward. Very sorry, folks, but we are already over. The final thing I want to say, and it's going to take 30 seconds. Don't cut me off. Is this is not being built in isolation or alone. A significant amount of people, the London one wasn't available yet, a significant amount of people were involved in building these things and in making these things ready for production. So please, when you decide to applaud, if you decide to applaud, please reserve some of that applause for those people. I'm not going to name people, because if I do, I'm going to forget someone, and that's going to be bad. But I'm looking around the room at a few of them that I can see. And with that, thank you. I don't think we can do Q&A. There is a QR code if you want to give feedback on the session. And yeah, thanks for coming.
Thank you.